Now, if we talk about the parts of a barcode, you see different lines, black and white lines. Some are thick, some are thin, but we will come to these lines in a minute. Okay, but first we need to discuss the lines which are longer than the other ones. Okay, so at the left hand side we have these three lines, black, white and black. Okay, this is called left guard bar, and then we have it in the center guard bar, and then the right guard bar. Okay, so when a barcode reader is reading a barcode, these left and right guard bars, they tell the barcode, okay, this is where you need to start and this is the end. Okay, so don't go beyond this, don't read anything before this. Here you need to start and here you need to end. And the center guard bar tells the barcode reader and the computer that this is the center of the barcode. Now, why center is important, we will come on this in a minute, and you may notice, and you must notice, I must say, that it is very important in barcode to tell the computer that this is the center of the barcode. We will discuss it in a minute, but before that, you see a number here, 075678164125. This is called UPC, or Universal Product Code. This is a unique product code for every product, and of course the barcode for that is also unique. And these numbers, these different numbers, different digits represent this barcode. So this barcode is a representation of this number, you can say. How? I'm going to tell you. So why left and right side? Why do we have the barcode divided, the product code, or you see here this center guard, it divides the product code into two separate parts, the left hand side and the right hand side. So every digit in product code is equivalent to 7 binary numbers, zeros and ones. Binary numbers are zeros and ones. So let's count these digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we get 84. So it means that this product code of 12 digits is equivalent to 84 binary numbers. Please keep every bit of information in your mind, otherwise you will not understand what is coming next. Now what happens is that 0 has 7 binary numbers. Okay, now you do not need to remember this pattern, the binary number of 0 and other digits. I'll show you how we are going to change it. Okay, and 7 has its own 7 binary numbers, and then other numbers 5, 6, 7, 8, 1, 4, 6, 4, 1, 2, 5. Okay, so now if you count here all the binary numbers like this, 1, 2, 3, 4, 5, 6, 7, and then so on, it adds up to 84, because it says as every digit in product code is equal to 7 binary numbers. 12 multiplied by 7 is 84. Moving forward, now notice these two different binary numbers. You see here that this is number 6, and the binary number of 6 here is 0101111. But the 6 here we see has a binary number that is 1010000. So they both are different. Of course, this one starts from 0 and this starts from 1. This one ends in 1, this one ends in 0. Why is that? That the digit is same, but the binary numbers are different. Now here comes the right and left part, that you see the barcode here, it is divided into two parts. This center guard is dividing it into two parts. So the numbers on the left hand side, in this case this area, every digit in this area has a different numbers, different binary numbers. And if the same number is on the right hand side, it or they will have different binary numbers. Okay. And where to get all these binary numbers, you don't need to memorize them. You will get a pattern in examination if you are given this kind of question that you need to change a UPC, universal product code, into its binary equivalent. The pattern will be given. Okay, you just need to memorize this information, that first, whenever you are given a binary number, just divide in half. Okay, for example, if you are given only this area 075678, okay, this is the whole, if this is the whole product code, that divide it in half, and then left hand side and then right hand side. You must have two different sides, left and right, and every side should have the number of digits should be same. And of course and always, the number you will be given will be an even number. For example, a product code of 4 digits, a product code of 6 digits. So you can easily divide into two, like 3 this on the left hand and 3 on the right hand. Let's move on. So now we are going to convert a UPC into binary code using its pattern. I told you that you will be given a pattern, and using that pattern you will be able to convert a universal product code into its binary equivalent. Let's see. This is the pattern. It's also given in O-level computer science book. Now you see here that left hand side has a pattern and right hand side has a pattern. So we are going to change this UPC, universal product code, into its binary equivalent. The first thing you need to do is, when you are giving a product code, you draw a line to divide it into two parts, left part and right part. Okay, and then you write it at the top, just so you will not get confused at the time of converting the UPC into binary numbers. You will get confused, so please make sure that you write left and right, and then you draw a line. Now see that we have 7 here, and because it's on the left hand side, so we are going to use the pattern on the left hand side, and on the left hand side 7 is here. Now how to read this this pattern is that, do remember that every light area, that light means white or any light color, is 0, and every dark or black is 1. So if we change this one into binary, it will be something like this: light, dark, 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 light, dark, dark. Okay, light or white is equal to 1, dark or black is equal to 1. Light or white is equal to 0, dark or black is equal to 1. So what happens is that we get a number 0111011. It means that we first saw this pattern, we wrote it here. Because it was white, it was a light color, so we wrote L. It was a dark color, so we wrote D, and we had 3 dark boxes, so 3 D's were there. We had 1 light box, so 1 L was there. Then we had 2 dark boxes, so we had 2 dark or D's here. And then we changed this again into binary numbers. L means 0, D means 1, so we got this number here. Okay, and do remember that we are converting the number on the left hand side, so that's why we are using the pattern of the left hand side. Let's move on to the second number. Second number is 8 here, and this is the number 8 here. So we start from light, dark, dark, light, dark, 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 L, double D, L, triple D, and then the binary equivalent of this would be 0110111. Okay, now last digit on the left hand side is 3. Now 3 is L L double D double D L D, and binary number of that would be 0111101. Now we have changed or converted all the digits of the product code on the left hand side into its binary equivalent. Now we are coming to the right hand side, and yes, if you guessed it, then you were right that we are going to use the pattern on the right hand side now. Okay, so first digit is 8, and 8 on the right hand side box is here. Okay, it means 1000100. So I write it here back. The second number here is 5. Okay, so 5 is here, and what would be the equivalent of 5 is 1001110. We write it back here to form a number, the equivalent binary equivalent of this whole product code. And then the last number of this product code is 2, and 2 is here. Okay, and the last one here we have it converted. Okay, so this whole number starting from here till here is your binary equivalent of this product code. Here I have it written properly. Okay, so you see that in examination you are going to write it something like this. Just give a small space after every 7 binary numbers of each digit, so it will be easier for the examiner to check, for your teacher to check, and for you, that you will not be confused at the time of conversion, because students, they usually mix up these numbers if there's no space. Now what we are going to do is we are going to change this whole pattern into back again its like barcode. So let's say we have 0 here. So 0 is equivalent to light color or white. So we have one white line here. Then we have 1 1. Okay, so we make a black box, a black line. Then we have 1 again, so one more black line. Then we have 1 again, then one more black line. 0 white line, 2 ones, 2 black lines. You see, now you get the idea that why there are some thick lines in the barcode, some thin lines in the barcode. Okay, it is because there are many ones or many zeros at the same time. That's why the lines, some are thick, some are thin. So we are changing this whole number, whole binary number, into one big barcode. So it would be like this at the end. Okay, this whole pattern, if joined together, it will form something like this. Now this is your barcode. Okay, this is an actual barcode. I took this from Google. Okay, I don't know which product is this, but this is the one that we just made out of this binary number. If we go back again, this whole binary number, this is the product code, this is its binary number, and this here, and I'm going to combine it again, is the barcode. Okay, of course, just to show you properly, I have made these lines very thick, otherwise it would have formed something like this. This is a neat and clean barcode, but the one I have made is has very thick lines, and it is very, you know, combined together it becomes a very you know, the width is very big. Okay, how does it work? Now we have seen that what is barcode and what it is made up of, how it is made. Okay, now we are going to see how does a barcode work. The barcode is first read by a red laser or red LED, light emitting diode. Okay, you may have seen, you must have noticed when the cashier, the person at the checkout counter, he's you know, scanning your products. He when he scans the product, a red light flashes from, you know, the barcode reader, the device. So that is LED. Light is reflected back of the barcode. The dark areas reflect little or no light, which allows the barcode to be read. Now light hits the barcode we have just seen, and then it reflects back of the barcode. Okay, so what happens that when the LED, the red LED light hits the dark area, the black lines, it reflects very little or no light. Okay, that allows the barcode to be read. The reflected light is read by the sensor. Through the reflected light, a pattern is generated which is converted into digital data. This allows the computer to understand the barcode. The dark lines, they reflect very little light. The white lines reflect more light. So what happens is that dark light DL, something like this, it generates a pattern. For example, the digit 3 on the left generates the pattern LDDDLD, where L is equal to light and D equals to dark. This has the binary equivalent of 0111101, where L is 0 and D is 1. We have already seen how the barcode is made. It is made on like using this simple method of light and dark lines, where L is 0 and D is 1 or dark is 1. So when the light reflects back, it generates this kind of pattern, and then pattern is changed into binary numbers, because computer only understands binary number. If the barcode is not scanned correctly, the barcode number is typed in manually using the keyboard. What happens after a barcode is read? Okay, so computer generated a pattern using the reflected light. That pattern was changed into binary numbers. Now what happens? The barcode number is looked up in the stock database. The barcode is known as the key field in the stock item record. This key field uniquely identifies each stock item. Let's see here. The big stores, they have a database. You may have seen something like this in Microsoft Excel, where you have rows and columns. So something like this they have saved in their computer, in their database, about all the products. So, in big stores they have thousands of products. So the product details, their UPC number, their UPC number, their price, the quantity they have left, and if they want to order more, and the serial number. So this is the UPC is the key field. So when this product code is looked up, when this product code was finally found using the barcode reader using the reflected light and then light and dark pattern and then binary numbers, so this product code is finally found, and when it is found, it is searched in this database. So in this case, maybe this barcode was scanned and this is searched. Spaghetti small, price is 120 and quantity left is 11. So it is searched. Now what happens when the barcode number is found? The stock item record is looked up. Of course, it is looked up, the price and everything, okay, details. The price and other stock items details are sent back to the checkout or point of sale terminal. So from the database, these details, they come back to the computer where your bill will be generated. Okay, that is also called point of sale, POS. The new value of number of stock item is written back to the stock item record. What happens is, if we go back here, I said that okay, maybe we searched about this one, we scanned an item which was spaghetti small, okay, and you have bought this item, one piece of this item, you have bought it. So what happens is that barcode is made or is used for stock management mainly. It is not for that you get the bills in printed form. It is not because it is fast and everything. It is because the shopkeepers or the owners or the big stores, they can manage their stock. At the end of the day, they do know or they do have the record that how much or how many things they have sold and what is left, and if they need to order more. Okay, so the quantity, they don't have to count every product, that how many of this product is left and do we need to order more. They don't need to count everything. This all is managed automatically. When one of any of these items is sold, the quantity is updated. Of course, if I bought one of this product, it will become 10. So that is what next slide is all about. The new value of the number, this new value for number of the stock items is written back to the stock item record. So you see now it has become 10. Previously it was 11. I bought one pack of this spaghetti. Now it is 10. The number of stock item is compared to the reorder level. Now one thing to notice here, that the last column say order more. So in their software, they have this condition, for example, that when this item is less than 11, the quantity is less than 11, then order more. It means send an email to the company to buy or to send 200 more of this product. Okay, so this is done automatically. The product quantity is updated every time one product is sold. The quantity is updated, and then there's a condition on, maybe on this, the same condition applies to all the products, or maybe a different condition for different product. Okay, so it means that for this soap, it says that when the quantity is less than 100, order more. For this product, when the quantity is less than 50, order more. Once an order for more stock item is generated, a flag is added to the record to stop reordering every time the stock item barcode is read. It means that, okay, the item is less than 11, order more. Order more means now there's a flag or an icon here that says that, okay, I have already sent an email to the company to send me more. Now don't send email again and again every time this barcode is scanned. Otherwise, every time computer scans this, it says, okay, yes, it is less than 11, so order more, order more, order more. Then they will have so many orders at the same time. So this is, a kind of a flag that tells that, okay, it has already been ordered, you don't need to order again and again. So you see that their database is managed, their stock is managed automatically. When new stock items arrive, the stock levels are updated in the database. So when they arrive, they need to update this database, and again it becomes maybe 150 or 200.